All right, guys. Welcome back. Another lesson. I'm recording this on Friday, so I'm happy. Can't wait. You guys will probably be watching this on Monday. But today we're going to talk about pairs of angles, okay? So this is kind of like a continuation of the previous lesson. All righty. So let's talk about some basic angles here. First one, complementary, okay? That's when two angles, they add up to 90 degrees. So the measurement of A plus the measurement of B equals 90. Making sure we use proper notation, M's for measure, okay, equal sign there because we're talking about measurement. The other way we know is by this box, right? We talked about this before in the previous lesson. That box means that it's a right angle and it is 90 degrees, okay? Don't ever assume, because here's the deal. If they don't say that this is 90, this could be off by 0.1 degree, a tenth of a degree, and it's obtuse, not by much. And therefore, these don't add up to be 90. So never assume. Okay, that's the warning I want to give you. Supplementary angles, they add up to 180 degrees. That should sound familiar. So these are just descriptors. And you can see that A and B, the measurements of them add up to 180. Why is a line 180 degrees? Well, isn't that half a circle, right? If you look at a circle visually and you cut it in half, that line is 180. Okay. Congruent complements and supplements theorem. What's this whole thing about? Well, let me tell you. Okay, actually, let's read it first. The first one says, if two angles are complementary to the same angle, then they must be congruent. Okay? All right, let's see that. So here's one angle, here's another angle, and here's another final angle here. Okay? This is 60 degrees. Now, if these two angles are complementary, then this must be 30, right? They have to add to be 90. If these two are complementary to each other, then this must be 30 degrees as well. So the complement theorem states, hey, if they're both complementary to the same angle, aren't they the same measurement? They are, right? Supplement is the same way. So we change this. Okay. The supplement theorem states that if these two angles are supplementary, so this must be 80, has to add to 180. If these two are supplementary, and this guy's 80, then aren't the other two angles congruent to each other? They are. Okay. So that's what those two theorems are just stating there. I think this visually does a better job than the actual statement itself. So for the example, the two examples, it's the pictures that I drew there. Okay? So finding complementary and supplementary angles. I have two pictures here. Okay, and we're going to go ahead and do this together. So find an angle complementary to KLM. Comp 2. So complementary means adds up to 90. Now notice we have one part of the picture that is 90. That's this guy right here. So this angle we're ignoring. So KLM. Those 3 points are in this region, this angle. So that must be this guy we're looking at, right? Because it adds up to 90. So that's going to be angle JL. Or KLJ if you go the other direction. Keeping in mind, because we talked about this before, the middle letter is always your vertex. So that's L. So that has to be in the middle. But the other 2 points we can flip-flop. Okay, last one. An angle that's supplementary to angle DGF. So here's D, G, and F. So what angle can be supplementary to it? Well, supplementary means adds up to 180 degrees. So we know lines give us that, right? So look at this line. This line is composed of this angle plus this angle. Okay, so that must mean that this guy is supplementary. So, angle D, G, E. And you could go the reverse order. one more. Or, do you see it? See how I can go the other direction, vertically? Here's my line. These two angles add up to 180 then, right? So you could also say angle FGC. Okay? Does that make sense? So 2 ways of looking at that picture to find supplementary angles. Okay? Next up, let's figure out these measurements. And once again, pause the video so you can write this down. Okay? Well, let's go for the 90-degree angle one. That just kind of pops out to me. So this whole thing's 90. So 55 and x add up to be that. So what would x have to be? Well, I think it's going to be what? 35 degrees? Okay. We got that from 90 minus the 55 because they were complementary angles. Next, let's figure out what y is. Okay. Now y, the 55, the 35, and the 40, see how they're all on that line? So the total is 180 degrees. So I have to add all these up to give me 180. Okay? Remember that's called the angle addition postulate? So let's do that. So y plus, now instead of adding these individually, I'm just going to put 90 there, right? So 90 plus the 40 gives me 180. So it's a lot of subtraction. So it's just y plus 130 equals 180. Y is 50 degrees. Okay? Now, we could say that this guy, angle DBA, is supplementary to angle DBC, everything here. See how I kind of combined the angles into one big angle, DBC, and DBA. They're supplementary to each other. So you could interpret it that way too. Okay? Not too bad, right? Just 90 and 180. Just got to keep that in mind. Okay. Adjacent angles. Another descriptor. However, they don't have any special relationship right now. Adjacent, just like in a normal context, just means they're next to each other. Okay? Like I'm adjacent to this board if I'm leaning against it. Okay? Two angles in the same plane that share a vertex and a side, but no interior points. So look at the examples I gave here. So angle TSL, this middle angle, is next to this guy, which is LSM. So they're next to each other. They have a common side, right? Ray SL is that common side. And the interior of both of them are separate, right? They don't share an interior. Look at the other example, left side. This angle is next to angle TSR, okay? Or RST, how I wrote it here. Doesn't matter the order, as long as the vertex is in the middle. And these are next to each other. They share this side, ray ST, and they have no interior points in common, okay? So it's just locating things. It's like, okay, what's adjacent to this angle? When you hear that word adjacent, you're thinking, oh, what's next to it? Okay? A lot of vocab here. Now, what can we do with adjacent angles? Well, there's one type that we have, and it's called linear. So a linear pair of angles are adjacent angles whose non-common sides are opposite rays. Okay, that's important. So not only are these two angles next to each other, they share a side, but their opposite sides are opposing rays. Opposite rays. I have to use the word opposite so many times. Okay. So if I had other angles in here, I'd have to be careful. I got to combine those angles, just like I did in the one example, to say that they're linear. Now the linear pair theorem states if two angles are linear, then they're supplementary. I think that's pretty intuitive, right? See how they're on a line? A line is half a circle. It's 180 degrees. So yeah, it should be supplementary, right? That's definition. Okay. So let's identify some angle pairings. So we're going to identify some linear pairs. And we're going to identify some adjacent pairs. Remember, adjacent means they're next to each other, but there's no other specific criteria. They're just going to be next to each other, and they don't share exterior points or interior points. So let's do adjacent first. Let's just name some angles that are next to each other. So we could say this guy and this guy, right? So that's going to be angle. I was going to write the word angle. Angle AFB can be partnered up with angle BFC. Okay, so there's one set of angles that are adjacent. You want to just keep going? We could say what? These two are adjacent to each other. So we could say angle BFC, angle CFD. Okay, not too bad, right? Let's do something different now. What's adjacent to AFC, this whole thing? I think it's going to be this guy over here, CFE, this whole thing, right? See how I kind of combine some angles together? So angle AFC, angle, let's go outside in, so we'll match it, EFC. I'll switch it around. Now, there are more in the picture, okay? But there's some examples to get you going. Now, linear, you got to be supplementary. That is important. Okay, we can do that. So, oh, wait a minute. I think I named them. Hey, how about these guys, right? AFC, this chunk, right? These angles combined. And EFC, this chunk, this angle's combined. They both share a common side, FC, and you see how the sides they don't share are opposing rays? I think that matches it, right? So I'm going to rewrite that in AFC, EFC. There we go. How about that? There's more. Let's try another one. AFD, that's this entire thing. What would be supplementary to that guy that's linear? I think it's going to be this guy, right? EFD, right? So let's write this down. AFD and EFD. There's another pair of linear angles. Another set of angles that are a linear pair. Now, saying all these words sometimes it gets tied up in your head. Okay? Are there more in the picture? Absolutely. But we'll just stop there. At least we got a list going so we can see what they are. Okay? Just when you think there wasn't any more, there are. We're actually nearing the end here. Vertical angles. Now, the description, I don't know, might be confusing, but I think the picture does a better job of explaining. Vertical angles are two angles such that the sides of one angle are opposite rays to the sides of the other. In other words, when two lines intersect, they form two pairs of vertical angles. So look at that picture I drew over there. I color-coded it so you can see. 1 and 3 are vertical. Okay? See how they, well, first off, they have, see, this is why it's Friday, I can't talk. We could see that they're opposite rays to the side of the other angle, right? Okay, so those are occurring. And you can see the lines are intersecting. Look at 4 and 2. They're the other set of vertical angles. There's my other pairing. Now, the vertical angle theorem states that they are congruent. Now, visually, you could probably see that. Like, these two look like they're the same. If I took this angle and I folded it over the other angle, it should be a perfect match. Same thing over here. If I took this angle and folded it over to the other angle, we're going to get a perfect match. So they're going to be congruent. Why? Is there a way to prove that? I think there is. I'm going off the lesson thing. I'm improv. So let's talk about that for a second. Okay. Let's say this angle is 50 degrees. All right. So this angle, because they are linear, have to add up to 180, right? So that must be 130 degrees. So that's what this. See how these two lines, or these two angles, are on that line. Now, look at this direction. Aren't these two angles linear, right? They add to 180. So if that's 30, this has to be 50. Hey, how about that? And we can go the other direction, right? These guys are linear. They add to 180, so this must be 130 degrees. So yeah, vertical angles are congruent. Is there a way to prove that for all measurements? Because here's the thing, that works for just that example. I have to do every number that exists to show that that works all the time. That's exhausting. So let's do this. Let's just put some variables in there to show all cases work. So this is like a proof in a way. So I'm going to prove that the measurement of angle 1 equals the measurement of angle 3, no matter what numbers you put in. So let's do that. So how we said the measurement of 1 and the measurement of 2 is 180. That's because they are linear, right? Then look, 2 and 3, measurement of 2 plus the measurement of 3 equals 180, because they also are linear. There's a lot of ways to prove this, by the way. We could do something different, and I'll talk about it. You see how both sets of equations add up to the same thing? If that's the case, then these two must be equal to each other. So I can substitute here. So the measurement of 1 and 2 equals the measurement of 2 and the measurement of 3. That's a substitution step because they both equal 180. Now look at this equation. I think angle 2 could be canceled, right? See how they both have angle 2? When I subtract them, they're gone. So look at this. Measurement of 1 has to equal the measurement of 3. And we got there by subtraction. Ta-da! So no matter what number I plug in, this is always true. This proves it for all cases. That's pretty cool, huh? Small proof. We're going to be doing proofs a lot in this course, but just to show you, we did it by numbers, which is a single case. Now we did it by variables, which does all cases. What's the other way we could do this? You ready? Angle 1 is supplementary to angle 2, right? Angle 2 is supplementary to angle 3. So angle 1 is congruent to angle 3 by the congruent supplements theorem. The thing that I just showed you at the beginning of the lesson could be used to prove that 1 and 3, that they're vertical and they're also the same measure. All right, just took an extra 5 minutes, but I just want to show you the reason. There's a reason why vertical angles are congruent. Okay? Kind of cool. Alrighty. So, let's solve this, just to get a little bit of practice with some algebra here. Okay? So now since we know why they're congruent, let's use the theorem. And solve for this guy. Solve for some x's and y's. Now, these guys are vertical, right? So they're congruent. I'm going to put arcs there to show it. And if they're congruent, they have the same measure. So 2x minus 5 equals x plus 30. Okay, solve for x. We'll get the x's together. X minus 5 equals 30. Then we add the 5, we get x to be 35. We should check our work. So let's plug 35 in to make sure they both work. So 2 times 35 is 70, minus 5 is 65. 35 plus 30 is 65. Boom, we're good. They're both 65 degrees. Now let's find y. These are vertical, so I'm going to put congruent arcs. And notice I'm putting 2 there. Why did I put 2? Well, because they're the only ones congruent. If I only put 1 arc there, for both of them, it looks like all 4 angles are the same measure, which isn't true. That can happen, though, if they were all, perpendicular to each other? But anyway, y plus 17 equals 2y minus 81. Take the y to the other side. So 17 equals y minus 81. Add 81 over here. So y is going to be, 91, 98? For that guy. Okay. So we can plug these back in, right? So 98 plus the 17, 115. 2 times the 98 minus the 81, I think that gives me 115, right? Be 196? Minus the 81? Yeah, that'd be 115. So now, these are the same. But here's the cool part. If that's 65, I'm going to write this down. If that's 65, if this is 115, see how they're on a line? They both add up to 180. So that's the other way to confirm, right? And it works the whole way around. So when you plug your numbers back in, not only should they be congruent by vertical angles, but they should add up to 180 due to linear angles, okay? Because they're supplementary. Which, hey, that's awesome. To be able to go back to your problem and easily check your work, that's a great tool. Great thing to know. Okay, last slide. Perpendicular lines. Okay, so I have a horizontal and vertical line here. They're just 2 lines that intersect that form 90 degrees. Okay, so that box, remember, that indicates 90. We do have a new symbol, okay? And that would be this guy right here, this little upside down T. Now that, in of itself, looks like they're perpendicular lines, right? So the symbol matches the description. Most things in geometry do, okay? When you name a line, you draw a line symbol above it. When you name a line segment, you put a line above it, which is like a line segment. If you name a ray, you're drawing a ray above those 2 points. So if I'm naming perpendicular lines, I'm drawing perpendicular lines as a symbol. So it does match up, okay? If this is 90, I know this is 90 because they're vertical, right? These guys are 90 because they're linear, out to 180. So are these guys, so are these guys. So that's one case where, I kind of said it before, where all of them were the same measurement. But that's only if you have perpendicular lines. Okay? That's it, guys. So that's pairs of angles. A lot of vocabulary. Supplementary, complementary, adjacent, linear, vertical. 5 terms, okay? So please make sure that you're looking through your notes. Make some flashcards, okay? Draw pictures of them on the other side so you can interpret and understand them. But other than that, that's all I got for you. So, hey, have a great day, and I will see you all in the next video.